Hi, hello friends, welcome to our channel Study of Mathematics. Hi friends, in this video we will discuss the next problem on the exercise 3e of section 2, problem number 2. The problem is if 3a equal to the matrix 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 1, then show that A inverse equal to A transpose. This is our given matrix. We have to given a matrix of 3a. From using 3a matrix, we convert it into A matrix, and then we have to find A inverse value and also A transpose value. Then we have to show A transpose is equal to A inverse or A inverse equal to A transpose. Then we will go to solution. First write down the given matrix is given that 3a is equal to 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 1. And from this a equal to 1 by 3 into 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 1. This is a given matrix A. We have to show A inverse equal to A transpose. First we can calculate A transpose value and then calculate A inverse value. Then first calculate A transpose. A dash equal to 1 by 3 into 1, 2, minus 2, 2, 1, 2, 2, minus 2, minus 1. This is A transpose value. A transpose value is 1 by 3 into 1, 2, minus 2, 2, 1, 2, 2, minus 2, minus 1. Next, we have to calculate A inverse value. If A inverse is exist, if the given matrix A is a non-singular matrix, for that first we can calculate determination of A. Then determination of A is equal to, here determination of A can calculate directly. If a given matrix has only the matrix form, then the determination is we know. But in this we have the scalar multiple of the matrix. A has given in the scalar multiple of the matrix. If we know, one of the property is that the given matrix is in scalar form, that or a matrix A equal to K into capital B. If a matrix A equal to small k is a scalar into the matrix form, then that determination of A equal to K whole power, the number of rows containing that matrix, K cube into determination. You can calculate the remaining matrix determination. By using that property, we can calculate this as 1 by 3 whole cube into this scalar determination value 1 by 3 whole cube into determination of this matrix. Then 1 into minus 1 plus 4 minus 2 into minus 2 minus 4 plus 2 into 4 plus 2, 4 plus 2, that is equal to 1 by 27 into 1 into 3 minus 2 into minus 6 plus 2 into 6, that is equal to 1 by 27 into 3 plus 12 plus 12, that is equal to 1 by 27 into 27. 27 ones are 27 ones are cancelled, that is equal to 1. This is not equal to 0. Therefore, determination of A is not equal to 0. Then we know that A is a non-singular matrix. Then A is a non-singular matrix. And then A is invertible. If a matrix is a non-singular matrix, then that matrix has a invertible. Then if A is invertible, then first we have to find the adjoint of A. The adjoint of A meaning is that the transpose of the cofactor matrix of the given matrix. For that, first we can calculate the cofactor matrix of the given matrix. Given matrix is nothing but the capital A matrix. The cofactor matrix of the given matrix. The cofactor matrix of the given matrix. Then next, the cofactor matrix of the given matrix is, we can multiply 3 with 1 by 3 with each element. 1 by 3, 2 by 3, again 2 by 3. This is A equal to 2 by 3, 1 by 3, minus 2 by 3, minus 2 by 3, 2 by 3, minus 1 by 3 is, let it be B. We can calculate the cofactor matrix of this matrix. The scalar multiple into matrix cannot find the cofactor matrix. Then first we can multiply the scalar with each element in the matrix and then calculate the cofactor matrix. Here cofactor matrix multiply cheyaniki manaku maamuluga A equal to scalar 1 by 3 into this matrix ఉంది. కానీ అలా క్యాలిక్యులేట్ చేస్తే వేరే వాల్యూస్ వస్తాయి కాబట్టి ఆ స్కేలార్ని మ్యాట్రిక్స్లోని ప్రతి ఎలిమెంట్తో మల్టిప్లై చేసి వచ్చే మ్యాట్రిక్స్కి కోఫాక్టర్ మ్యాట్రిక్స్ని ఫైండ్ అవుట్ చేస్తాం. ఆ వచ్చే మ్యాట్రిక్స్ ఏ ఈక్వల్ టు 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3, minus 2 by 3, minus 2 by 3, 2 by 3, minus 1 by 3. We can calculate the cofactor matrix of this matrix. The procedure is same as previous problems. Then the cofactor matrix is 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3, minus 2 by 3, minus 2 by 3, 2 by 3, minus 1 by 3. This is a cofactor matrix. Then adjoint of A equal to, here we calculate adjoint of A, that is B transpose. B transpose value is 1 by 3, 2 by 3, minus 2 by 3, 2 by 3, 1 by 3, 2 by 3, 2 by 3, minus 2 by 3, minus 1 by 3. This is a adjoint of A value. Then we can calculate first A inverse value. Then A inverse equal to adjoint of A by det A. That is equal to det A value is 1. Then 1 by 1 into adjoint of A value 1 by 3, 2 by 3, minus 2 by 3, 2 by 3, 1 by 3, 2 by 3, 2 by 3, minus 2 by 3, minus 1 by 3. This is A inverse. A inverse equal to 1 by 1 value 1. And in all elements we can common 1 by 3. Then 1 by 3 into 1, 2, minus 2. 2, 1, minus, 2, 1, 2. 2 minus 2 minus 1. Then by observing A transpose equal to in previous steps we can calculate A transpose value. Then in that A transpose equal to 1 by 3 into 1, 2, minus 2, 2, 1, 2, 2 minus 2 minus 1. Then this is equal to A transpose. Therefore A inverse equal to A transpose. This is the solution of this problem. In this problem there is no confusion. First we can give a 3A matrix. 3A matrix equal to matrix form. From this we can calculate A by sending this scalar 3 into other side. Then A equal to 1 by 3 into matrix. Then First, A transpose can be calculated. After that, we can calculate A inverse value. For finding A inverse, we can first check whether the given matrix A is a singular or non-singular. If the given matrix is non-singular, then we have to calculate the A inverse value. Then further, we have to calculate determination of A. But in this problem, we have A equal to 1 by 3 into this matrix. 1 by 3 means the scalar. By using the one of the property in determination of matrices, we can calculate the determination, that is that A equal to this scalar 1 by 3 whole cube, the number of rows present in the given matrix, 1 by 3 whole cube into determination of the remaining matrix. Then by calculating that, we can get determination of A equal to 1. 1 is not equal to 0, then that is determination of A is not equal to 0, then the given matrix is a non-singular. If a given matrix is non-singular, then A inverse is exist. Then for finding A inverse, we have adjoint of A value. Adjoint of A is nothing but the transpose of A, the cofactor matrix of the given matrix. Then first find out the cofactor matrix. We have to find the cofactor matrix of A. In this, A is nothing changed, but in this, the scalar multiply 1 by 3 can be multiply each element in the matrix. Then we have to find the cofactor matrix of this A. Then the cofactor matrix B equal to 1 by 3, 2 by 3, 2 by 3, 2 by 3, 1 by 3 minus 2 by 3, 2 by 3, 2 by 3 minus 1 by 3. This is the cofactor matrix. Then adjoint of A equal to B transpose. B transpose value is this. Next, we can substitute A inverse in the same adjoint of A by det A value and adjoint of A value. This is the matrix. Here 1 by 1 is 1. Here both all elements have the 1 by 3 term in common. Then taking that element as common, 1 by 3 into matrix, we can, in previous method, we can calculate A transpose value. Then that A transpose value, the finalizing A inverse value is or equal, then A inverse equal to A transpose. Therefore, A inverse equal to A transpose. This is the solution of the second problem. Thank you for watching.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.